Hello, my name's Frank, and today we're going to solve some basic equations. So I have a miscellaneous set here for you. Hopefully you've had this in some of your previous math courses, but it's a good general review to start you off. So I have 6 questions, and I'm going to work them step by step. So let's look at the first question. It's 5x minus 1 is x plus 11. Now, depending upon how you've been taught, how you approach a question, you would like to get all the x's on one side and all the numbers on the other side. It's like walking up a stairwell. Whoever makes the first step, we all follow. So what's the first step? You could bring the x over to the left. You could take the 5x over to the right. You could take the negative 1 to the right. You could take the 11 to the left. It's up to you. Most people like to start off with the x on the left. So we'll start the first one like that. So how do you get rid of a positive x? You take the opposite of it, which is a negative x. How do you get rid of a sweet taste? You put something sour. How do you get rid of a cold? You put something hot. You negate it. So you put an x on the left, and you put an x on the right. Some people draw a vertical line down there, so what you do on the right, you do on the left. Others don't. Now, if you have 5x take away 1x, that's 4x. And you bring down your minus 1, and then x take away x disappears because it's 0. And that's equal to the 11. Okay, so you have the first step done. You have the x's all on the left. Now, we need to get rid of a negative 1. So how do you get rid of a negative 1? You take the opposite, which is a positive 1. You do it to the left, and you do it to the right. Remember, you got to do it to both sides to keep it balanced. Well, you have 4x. Negative 1 plus 1 disappears. It's 0. And 11 plus 1 is 12. Okay. Now, 4 times x. 4 times x is a multiplication. So how do you get rid of multiplication? You take the opposite of it, which is division. So we divide by 4, and that will eliminate the 4. 4 divided by 4 is 1. 1x. You don't need to put the 1. You could. If you go into a store and say, I want a soda, you don't need to say 1 soda. It's understood to be 1. So you could put 1x or just x. And 12 divided by 4 is 3. And that's our solution to our first problem. If you were to put 3 in there for x on both sides, this would be a true statement. So I put a box around it to denote as my final solution. So there's your first one. Okay? Moving to our second example, we've added another twist. We put what was called 3 parentheses x minus 1. So that means we're going to multiply what's in parentheses by 3. That's known as the distributive property. So some students like to see this. It's 3 times x. And then they like to go 3 times negative 1. Other students don't need that step. Some do. So whichever. It's 3x minus 3. Then we add a 4 to it. And we get 28. Now, I would suggest before you start adding something to the right and add something to the left, you combine similar terms. It makes it quicker. Negative 3 plus 4 is the same as 4 minus 3. Well, 4 minus 3 is 1. So you can combine them 2 terms and get 1. Okay, now, we have the x on the left. We need to take the 1 to the right. So how do we get rid of a positive 1? We subtract 1. We take the opposite. And we have 3x. The plus 1 minus the 1 goes to 0. 28 take away 1 is 27. Now, the inverse operation of 3, the opposite of a multiplication is a division. So we divide by this 3. And remember, 3 over 3 is 1, and you do not need to put the 1 in front of the x, but you can. You get x is equal to, and then 27 divided by 3 is 9. And there's our solution. Okay. The third example is another distribution problem, but I thought you may want to see this because a lot of times there's careless errors made on this, especially if the student is in a hurry. So the only difference is you have a minus sign in front of a parenthesis. So you distribute, but be careful, minus times a positive is a minus. Now minus times a minus times a minus is a positive. Plus 6x. So be very careful here. That's minus 3 plus 6x. Then you add your 6, and you set it equal to negative 6. Now I intentionally put a lot of 6's in here for you. You combine your like terms, just like we did previously. You have negative 3 plus 6. If I say that, sometimes that'll confuse somebody, but if I say 6 take away 3, it doesn't. So 6 take away 3 is 3, plus 6x is negative 6. Okay, we have our 6x on the left. We need to move the 3 to the right. To get rid of a positive, you take the opposite, which is a negative. And you get 6x. Now, if you remember, a negative times a negative is a positive. But when you combine them, think about if you owed somebody $6, and then you add another debt of $3. So you owe somebody 6, you owe someone 3, you combine them, you're $9 in debt. So there's the 9, and negative denotes the debt. So the simple rule is you add them and keep the sign. So 6 plus 3 is 9, and they're both negative. To get rid of this 6, you divide by 6, and we notice something. First off, it doesn't come out to a nice integer answer. Now, it can reduce. Negative 9/6 is not wrong, but you don't go into a store and say you want 9/6 or something. It would be easier to say, I want 3/2, because they're both divisible by 3, negative. But once again, you don't go into a store and usually say, I want 3/2 or something, but you could. Another version of that would be 1 1/2. You could say, I want 1.5 gallons of milk. So, any of these answers are right, but these two are preferable. Because this is reduced. So, depending upon your teacher, now there may be a teacher that would say, or negative 1.5. So, any of those answers are correct, whichever one you choose. Okay. Our fourth example is a fraction. Now, there's different ways to do these. If you look at the rules we decided previously, we said we will divide by 1/3, the number in front of the x, and I encourage that. That's a good way. But then that leads to inverting and multiplying. And that will only work if it's just 1/3 or 1 something times x. what happens when we start putting more fractions together like the next two examples? So I think there's a quicker way. The quicker way is to find the least common denominator of all the fractions. And that'll work no matter if you're teaching Math 1 or if you're teaching a calculus class. It's the same procedure. So example, you don't see a fraction under here. But you can make it into a fraction by putting a 1. So what's the least common denominator between 3 and 1? Now remember, the least common denominator is the number they both divide into. Well, you could say 6, they both divide into 6. You could say 12, but the least would be 3. And the reason you do least is the numbers are the smallest, and you don't have to reduce at the end. So put a 3 out there. And once again, the reason you do that is that's the number that both 3 divides into and 1 divides into. Now, I encourage my students to put that 3 up front. And by putting a bracket around it, that makes them realize they got to multiply both the left and the right by that 3. Now, what's 3 times a third? Well, another way of saying 3 times a third is saying 3 divided by 3. Well, 3 divided by 3 is 1. So you get 1. 1x. And then what's 3 times negative 4? Well, positive times a negative is a negative. And 3 times 4 is 12. And there you go. One step. We're done. One step. Now, a lot of people will say, well, that's not too bad. But let's look at the next one. I kid the students a lot. What's better than 1 fraction? 3 fractions, 4 fractions. Look at this, 3 fractions. Look, 4, 3, and 6. So you say, wow, the other one had 1. Now we got 3. How do we do it? Well, what was the rule? You find the least common denominator. What number will 4 divide into, 3 will divide into, and 6 will divide into? Do you know? Well, if you start exploring multiples of 6, 6 times 1 is 6. But 4 don't divide into 6. How about 6 times 2? That's 12. 4 goes into 12, 3 goes into 12. So there you go, 12 would work. If you wanted to, you could take bigger numbers than 12, but that's it. You make it bigger numbers, and then you have to reduce. So we're going to multiply everything by 12. What's 12 times 3/4? Well, think about it. If you had 3/4 in your pocket, which is 75 cents, and you bought 12 things for 75 cents, how much would you pay? Well, you can do it by multiplying 12 by 3, but then all of a sudden you're up there to 36. Why not do it the easy way? Do the division first. What's 12 divided by 4? You say 3. And then what's 3 times 3? 9. So let's go around again. I prefer to do it this way, the easy way. 12 divided by 4, 3. 3 times 3, 9. Done. What's 12 divided by 3? You say 4. 4 times negative 1. Negative 4. What's 12 divided by 6? You say 2. 2 times 5? 10. Isn't that amazing? One step, we've got their fractions all right from. Now your kids say they hate fractions. One step. No matter how many fractions. Now what do? We got the x's on the left. We take the negative 4 to the right. The opposite of a negative 4 is a positive 4. Negative 4 plus 4 goes to 0. So we get 9x is 14. Now, this problem, we need to get rid of 9. So the inverse of multiplication is division, and we divide. Now, 14/9 is correct. Other versions. 9 goes into 14 1. with 5 left over. And then there's a decimal equivalent that you could type in and get that. One of those two answers would be preferable. Now, if it's a calculator active problem, you could get a decimal equivalence. So there you go. But notice how easy the fractions were reduced. Taken care of. Our last one, that's one new twist, you got a decimal. 2.5 times x minus 1 1/3 is 5/6. So sometimes get students good with decimals, sometimes get students good with fractions, and then you mix them. They say, oh boy. So what should I do? Well, if you could get them all into fractions, you would be just like this. Or if you could get them all into decimals, I could show you that. But look at it. 2 are fractions, and 1's a decimal. So why not get the decimal into the fraction? 2.5. What's 2.5? $2.50. Isn't that $2.50? You say yeah. 2.5. Got it. Got rid of the decimal. Now, you got what's called a mixed number. Well, let's get rid of that, so we can do it like the previous one. 2 1/2. 2 times 2 is 4, plus 1 is 5. Isn't that equivalent to 5 over 2? 5 over 2 is 2.5 x. Let's do this again now. What's 3 times 1 plus 1 is 4/3. Is 5/6. Now let's look at that problem and compare it with that previous problem. It's the same concept now. How do you get rid of the least common, these fractions? What number does 2 divide into? What number does 3 divide into? And what number does 6 divide into? Now, if you remember what we did last time, we took the biggest number, 6. Let's stop there. Does 2 go into 6? Yes, it does. Does 3 go into 6? Yes, it does. So why not use 6? Now, put the 6 up top. That'll remind you to do the division. What would happen if you went beyond 6 and used 12? The numbers would be bigger, and you would reduce at the end. What's 6 divided by 2? Brings it down to 3. What's 3 times 5? You say 15. What's 6 divided by 3? You say 2. What's 2 times -4? -8. And what's 6 divided by 6? Now that word cancels. Cancel means, I don't like to use it, it disappears. No, it doesn't. 6 divided by 6 is 1. 1's there. So 6 divided by 6 is 1, and 1 times 5 is 5. Now, what do we need to do? Get rid of the 8, the -8. The opposite of a negative is a positive. We add a positive 8 to both sides, and we get 15x is equal to 13. The inverse operation of multiplication is division. We divide by 15. And we get x to equal, and you ask yourself, does this reduce? Is there a number to divide, other than 1 that divides into 13 and 15? And you'll find there isn't, so there's your answer. Now today was a basic review of 6 questions. Hopefully you've had, and hopefully you'll be able to expand upon on our next lesson. I hope you found this good. See you next time.